All right. Hello, everyone, and welcome to yet another offline stream. While I'm on vacation. I don't speak English. I'm sorry. I'm trying to. All right. So today is Saturday, the day of the Saturn, right? That means today, according to the schedule, we're doing a game development in OpenGL and C++. As usual, so we continue to develop our game. So this is how the game looks like so far. So it's using OpenGL. It doesn't use any engines or anything like that. Well, you may say that I'm using a custom engine. It just depends on the perspective, right? So from one perspective, I'm not using any engine. From another perspective, I'm using a custom engine. It just depends on how you look at it. You know what I'm talking about? Yeah. So, and this custom engine is actually pretty cool. So it's a rewrite from pure SDL2. And in pure SDL2, we were not able to actually do this kind of effects where you can make an object shatter into like pieces, and also pieces maintain the textures and stuff like that, and they also disappear because it's not really easy to do in pure SDL2, because pure SDL2 doesn't really provide you that much power. So we had to go a little bit lower in the abstraction layer, because SDL is built on top of OpenGL, DirectX, and Metal. So we just went a layer down, OpenGL, and we unlocked a lot of computation power that we can finally use in our game. And I'm super happy, actually. I'm super happy. All right, before I start, I would like to actually shout out people who were donating while I was still on vacation. So first of all, Hamikovi, thank you so much for $5 donation, showing your sub. He donated it like while I was offline, when I was not even recording or anything like that. Thank you so much. And also, I got a new patron on the Patreon. Thank you so much, Susan Sun, for a generous 20 euros patronage. I don't even know how to call that. I quite rarely use a Patreon. So I do have a Patreon, and I had it for quite some time. I sort of reserved it for my main YouTube videos on my main YouTube channel. In any case, thank you. So if you still want to support me, I'll leave all of the links, all of the support links in the description. So I'm gonna just put something like this. So support links, something like this. All right. So let's start our development. You can find the source code of the game that we'll be developing on the GitHub. So the game doesn't really have any particular name, so that's why the repo is called like that. So game source code. So here we go, game source code. You can find the source code in here. If of course you are interested. If you're not, you can just watch me making pretty pictures. Well, it doesn't really look that pretty, I don't know, but I mean, maybe at some point it's gonna look interesting, but right now it is not. It is not. Okay, so let's go to the source code and see what we can do. I think I had a couple of issues. That I wanted to resolve. Yeah, recently we actually refactored our renderer, right? Our renderer is capable of rendering different things, specifically triangles. You can provide the geometry of a triangle, the color of a triangle that will mix into the texture, and UV coordinate of the texture. And then you can also provide a program, a shader program, with which you want to render that triangle, right? You can switch between different programs and stuff like that. So, and by the way, the texture coordinate is taken from our texture atlas. So all of the textures are consolidated into a single texture atlas, and also calculated their UVs. So you have to provide the UV coordinate inside of the texture atlas. So essentially that's what you have to do. So you can also render AABB, axis aligned boundary box, but it's essentially implemented in terms of filled triangles, because it just takes AABB and splits it into triangles. And we also had a circle. We also had a way to render a circle. And I'm not even sure, well, So essentially the way we rendered circles, right? The way we render circles we used to render circles actually, is the following. I just opened my Paint and accidentally closed it. It's a shame that my Paint closes faster than it opens up. Anyway, so we usually just render a quad, right? We usually just render a quad, and inside of a shader, right, we also sort of set up its UV coordinates, right? UV coordinates from 0 to 1, 0 to 1. And then we pass all that information to the fragment shader, and in the fragment shader, we already calculate the distance from the center of this quad, and we simply draw the circle, right? Usually, I mean, it's filled in, right? So this is how we usually do that. But then, like, we refactored everything and making, like, allowing the user to actually just render AABB and triangle and just specify the program that you want to use. So I feel like this particular function is sort of obsolete because now you can essentially just draw AABB with a special circle program, right? You just need to write a special circle program and just draw the regular AABB. But the cool thing about this function is that it doesn't accept AABB. What it does, it accepts the center and the radius. So what I'm thinking is that maybe we're gonna retain the signature of this function, but we're gonna rename it a little bit. And the thing that this function is gonna do, it's gonna simply take a point, this center, right? Then take the radius. Let me actually switch the brush. Take the radius, go up, and then go another radius in here, and this is gonna be the position of the AABB. Then go here and here by one radius, and this is the size of AABB. So basically, it will just render the AABB with the center that you provided, and radius is going to be the size. So on top of that, since it's going to be like pretty much the same thing, you also should provide not only color but the UV coordinates. The UV coordinates that you may want to have, but the question is, what's going to be the UV coordinates in that particular case? What's going to be the UV coordinates? That's a good question, actually. That's a good question. Maybe we won't provide any UV coordinates. Maybe it's always going to be automatically like 0, 0, 1, 0, 1. I didn't even know. I didn't even know. Okay, I'm gonna actually postpone that idea for a while because I'm not really sure what's gonna be UV coordinates in Atlas. Like how do you even specify? So I suppose UV coordinates in Atlas also should be like center and radius, but in the coordinates of Atlas. So that means I'll have to have something like v2 GL float UV center, and then GL float UV radius. But there's just too many things to actually provide, so I'm gonna just actually postpone that because I just want to fix the issue of implementing this fill circle. And the question is how I'm gonna call this this entire function if it's not going to be about the circles anymore, but let's actually call it keep calling it fill circle for now at least, and then maybe I'm gonna rename it to something else when, yeah, since I don't know how to call this function, maybe I just don't have enough information about that function, about what that function is. So I'm gonna leave it as it is right now. Maybe later is gonna be a little bit more clear. So, but we still use this function, by the way. We still use this function for particles, right? For particles, because the particles are usually rendered at a particular position with the center of particular position, and they're usually just quads, but with the texture generated procedurally, right? So that's basically what it is. Okay, so, and as I already said, we probably have to accept the program, right? We probably have to accept the program with which all of that is going to be rendered. All right, so let me see. So maybe we need to create a separate branch for this entire thing. The branch is actually 79, right? It's going to be 79, and let's get started. So I'm going to remove that. So this is the center, this is the radius, this is the color, and we're gonna accept program asset, right? Program asset, and program asset is the essentially the shader program, right? Program asset. All right, and I think implementation of this entire thing is relatively simple, right? Because basically you need to take the center and the radius and construct AABB out of that, and then just pass fill AABB. So that's gonna be it. That's essentially going to be it, I think. Okay. So let's do that. I'm gonna take the center and I'm gonna subtract the half of the radius. No, it's not the half of the radius, but the full the whole radius. Right. I think I should be able to do it like that. So if I take a look at the Geo HPP in here. Oh, and by the way, on the previous stream, I came up with a good name for this kind of library. So this kind of library is should be probably called something like LA for linear algebra. But again, here we not only have linear algebra, so I don't know how to call it. It's just like math libraries, because what could be not a linear algebra? I don't know. Triangles are not particularly linear algebra, but maybe they are. It's more like a geometry or something like that. It's just, it would be better to just call it math. And I think I could probably call it math because I usually put like some sort of a prefix for my modules in here. So yeah, and it's not gonna collide with like math.h or anything like that. So it's gonna be clear that this is the math module of my specific game. So yeah, I just don't like the name Geo. It's just like, yeah. I just don't like it. It's like it makes it sound like it's something about the, you know, geography or something. But yeah, it's just better. Let's just call it math. Right, it's a pretty abstract module, but yeah, it is what it is. All right, so let me go to the compilation errors and just fix all of them. This is not how we build this game. Apparently, we build it sh. I need more tea. I'm actually falling asleep a little bit. I'm very sorry. Just a second. Yeah, so I just need to go through all these places where it complains about that stuff and just replace everything. No biggie, no biggie, no biggie. Okay, so this is gonna be a math. There's another one. Maybe I could just find all the places where we use this entire thing by doing grep something geo, right? And there's at least like 4 of them, and this is one of them. This is another. You see, grep is better than the compiler at refactoring things. All right, so and then let me rebuild this entire thing, and I think it's gonna work quite well. Everything is working, hopefully. Okay, if it compiles, it works. You know the saying. If it compiles, it works. I want to run the game. Excuse me. And I think it is working. So let's do a committee, and then maybe even a pushy. All right. So it's gonna be 79. Rename something geo to something math. There we go. Did I do it correctly? Did I not make any stupid fucking mistakes, man? I think everything's okay. And let's push that right into the repo. All right, so let me unstash my changes and let's continue doing this kind of stuff. So that was a weird tangent, but yeah. So yeah, yesterday, by the way, I was working on the particle simulation thingy. And I'm gonna actually give you the link to the previous previous VOD or something, so you know the context of what I'm talking about. Particle simulation stream, and I had to implement my own linear algebra library, like a very small Nice video, Susan. Yes, I do remember that one. Yeah, I had to implement my own particle system. Not particle system, my own vector library to work with vectors. And this is because I was translating the code from Unity to C, right? So from C# Unity to C. And what I noticed in Unity is actually they made a very convenient overloading. So basically, you can have a vector, which is the center, right? And you can always subtract or add to the vector like a scalar, right? So usually in my libraries, I give an ability to multiply by a scalar because it's kind of like the usual thing that you do in math, right? In actual math, you have a vector, you multiply it by a scalar, and you scale that vector. But quite rarely in math, you just add a scalar to a vector or subtract a scalar to a vector. So mathematicians usually don't do this kind of thing. But in Unity, you can do that. And in Unity, it basically means, I think, this stuff. And it's actually quite convenient. It is actually quite convenient. So in C, it's kind of difficult to overload operators, but we can do that in C++. In C, what I had to do, I had to create like an alternative constructor of a vector from the radius, and it worked quite well. So I find this idea of like allowing the user to combine vectors with scalars, and if it's a scalar, just extend it to the vector, very, very powerful. It's a very powerful idea. It's actually quite interesting. So I never realized how powerful it is. And it just makes the code like more readable and more like concise and stuff like that. So I learned a thing or two from Unity. So specifically, I'm talking about specifically Unity mathematics module. Unity mathematics, yeah. Unity mathematics, this one. That's a pretty cool module. Even though I never programmed in Unity ever in my entire life, but from what I saw while sitting on Linux, it's actually quite cool. It's actually quite cool. Maybe at some point I'm gonna actually do like a Unity stream or something. But I would like to have a more powerful PC and preferably Windows, because I don't know, does Unity even work on Linux? Or because everyone I saw who develops on Unity, they're usually using Windows. Unity Linux, like how do you set up Unity on Linux? So let me see. Choose your Unity plus download. Okay. Oh shit, that's expensive, but I suppose it's like you don't have to pay it. Like, okay, I'm individual and I'm doing, okay, so I can do that. Personal, get started. So you have to sign up for something, right? Do I have to sign up? Can I just download? Can I just download? The more clicks I make, the more I lose interest in this thing. I'm sorry. And I lost it. All right. Anyways, maybe at some point we're gonna do a Unity stream. I don't know. I don't promise anything, but we'll see. We'll see. All right. So, and I was thinking maybe I can overload this kind of thing. Maybe I can overload it. So you can do it like that. But it feels like if you try to overload, you will have to overload a lot of things. So you have to overload something like vector2. And then the scalar, right? And then you have to overload the version where the scalar comes first, right? And so on and so forth. Basically, like you have a lot of combinatorial complexity. But on the other hand, if you just allow to construct a vector from a single scalar, you only need to implement a single operator, which works only on the vectors. Right, and then if you want to make it work on a scalar, you just call like this simple constructor that turns a scalar to a vector, and you automatically have a version where you have a different order of the arguments. You know what I'm talking about? So it's kind of like the binary operations that work only on vectors plus constructors that turn scalars to vectors is more powerful idea than you know, overloading different combinations, because this kind of idea compresses all that combinatorial complexity into like a couple of functions, like binary operation plus conversion from one thing to another. So Yeah, and to be fair, in Unity mathematics, there's a lot of combinatorial complexity. Right? If you take a look at how many overloaded operations and types and stuff like that there is, it's just like insane. It's a huge page. If you look my previous stream, that page, I went on that page and it was loading like for ages. I think I just. I was searching for that page for the thing that I wanted on that page. I found it. I read everything I wanted, and I closed it, and it yet didn't finish loading. It was kept loading. That's how huge it was. So yeah. Anyway, so there's a lot of combinatorial complexity. Maybe I'm gonna just keep things like this. I think it's pretty convenient. And do I even have an operator that constructs a vector out of a single thing? I think I do. Yeah, I do. Here's the constructor. So you can just provide a single scalar, and it basically constructs you a vector with these values. Okay, so and in that case, what I can do, right? I can take a center, subtract a radius, and this is the position of AABB. Right, this is the position of AABB, and the size of AABB is basically radius, but multiplied by 2, right? So multiplied by 2, because the size of this AABB is essentially 2 radii. First radii, so here is the first radii, here is the second radii. Radius. Oh my god. Plurals for nouns in English that end with s are really complicated. I don't understand them, I'm sorry. I'm a very stupid person. I'm just a stupid Russian. What do you want from me? Alright, so here is the AABB that we wanted to render, I suppose, and what I want to call in here, I want to call fill AABB. So this is the AABB I'm filling, and we're going to use the color for the shade. And what we're going to use for the UV coordinates? I suppose for the UV coordinates, we're going to just use AABB with a center at 0, right? And the size is going to be just 1, 1, right? So this is going to be simply 1, 1. Because that's precisely the things that we'll need to render a circle at the end of the day. And then we need to pass the program that we're going to be using to render all this stuff. Okay, I suppose that is it. I suppose that is it. What's interesting is that we already have okay, we already have things that use fill circle. I think we have particles, right? I think we have particles. And let me see if they use them. Particles, CPP, fill circle. Yeah, we do use these things. Here's the fill circle. And since we're using fill AABB, and the default program uses the UV coordinates in the atlas, this particle will appear with the chunks of the oh my, they will actually contain the whole atlas. They will look like a little bit weird. So we're gonna have particles with the texture of the whole atlas, like compressed and squished and stuff like that. It's gonna be funny. Okay, so let's see if it's gonna work. First we need to make it compile because we changed the signatures of some things. And then we'll see. Okay, so here I have to use one of the program assets. Let me see. So it's going to be a renderer, right? And what kind of program do I have to use? I have to use a regular program. I could have used particle program, but the particle program don't know how to work with our specific vertex attributes, so we'll have to change the particle program to actually be able to work with our vertex attributes. Okay, so let's try to recompile that. So is it going to compile now? It still doesn't compile. Let's take a look. This has to be f, because if you have a floating point literal without f, it's actually double, not a float. For float you have to use something like this. And are we good? Are we Gucci? Tamaguchi? Forcing E. Okay, so let's try to run this thing now. What do we get? What do we get? I don't know why I'm rebuilding the second time, but yeah. Yeah. What the fuck is this shit? It's so funny, actually. Yeah, this is precisely what I was talking about. These are particles, and yeah, so they're supposed to be red, by the way, so that's why they're... It looks so cursed, it like looks corrupted or something. Love it. fucking load. I wonder if I can demonstrate how the atlas actually looks like. Can I do that? I think I should be able to, because we store the pixels of the atlas as just like RGBA, right? So it's just RGBA or some whatnot. So I suppose the texture is actually the pixels of the atlas, and I wonder if I can actually save it to file. Okay, oh, here it is. So it's a width and height in pixels. You can even get individual pixels and stuff like that for some reason. Probably a bad idea. So you can save it to PNG file. Does it still work? Save to... Oh yeah, we use STBI, right? So yeah, I was using that for debug purposes. So at any point I can actually save the atlas to like PNG and look at it. My god, such an advanced engine, isn't it? All right, so where do we initialize the atlas? I think we're not initializing it. Let me take a look at the atlas, and maybe what I want to search for is the atlas from config. Right, so this is the atlas from config, and I'm initializing it here, and after that I can just do something like atlas texture, save to PNG file, atlas.png, and let me see if it's gonna work now. And so it's not texture SID, it's a single texture, okay? So it will just save that, and then we'll be able to look at it. So here is the atlas PNG, and let's open it in Feh. So here's the atlas. So here are all of the textures that we have. Probably Feh actually ruins the encoding. So we have to do something like background black, if I remember correctly. I'm not 100% sure. I keep forgetting how to make Feh to like have a specific background. Background B. Okay, so it has to be actually small characters. So it has to be B black atlas. Okay, that's what I wanted. I'm sorry. All right, so basically these are all the textures that we use, and we put them into a single atlas. Yeah, I know that the atlas is not like a power of 2 or anything like that. I'm aware of that and everything. So, but yeah, it's not that important right now. It's not that important. And what's interesting is that we have, okay, we have like these interesting margins, which are built at runtime, by the way. The original textures don't have this sort of margins or padding or anything. They're built at runtime, and these margins are needed to prevent the texture bleeding, right? So because yeah, because of the interpolation, some of the colors of one texture can bleed into another one, and it just creates like these ugly edges. So to combat that, we just put a little bit of margin. And it's quite cool that we do that like at runtime programmatically. So you can just add more textures, and these margins are going to be added like automatically for you. So yeah, that's pretty cool. And essentially what you see in here, what you see here in this corrupted mess is like each particle is the whole atlas squashed into a square and colored red, because that's the color of the particle. That's why it looks so cursed, because like this is not what you're supposed to see. I love it. So like it's like a glitch effect of some sort. Nice. Anyway, so essentially now, since we have a particles, we kind of have the fill circle implemented. It's just like we have to use a different program. Theoretically, in here we have to use a particle program, but the particle program is not adapted to work with the new renderer. So the next step is going to be adapting it to the new renderer. I didn't recompile anything. Okay, stage. Let's put it like this. Yeah, there we go. So as you can see, we're using program that is not meant to be used like that, and it also creates interesting effects too. So I'm not gonna lie, it also creates interesting effects. So yeah, it's kind of cool. It's kind of cool, not gonna lie. Especially if I'm moving and stuff like that. It's sometimes it tries to take a shape of the circle, but it's failing miserably to do so. Yeah, it's kind of interesting. All right, so let's do a committee. Let's do a committee, and maybe then even a pushy. So let's remove this thing. 79 implement. Well, wait a second. I don't want to commit the saving of the atlas. I think it's quite important. It's not needed. So basically, if I commit that, every time you run a program, it will save its atlas to the file system, and it's just not really what we want. It's not really what we want for the program from the program. Okay. 79 implement renderer from fill circle, right? Circle. Go, and I'm gonna push that right into the repo. And let's go ahead and take a look at the program. Let's take a look at the program. So we have a shaders, and for the particle program, if I remember correctly, right? If I remember correctly. So let me take a look at the renderer, and I want to find what are the file paths that we use for all of that. Where do we load up .vert? Or something like that. Okay, so here is the one shader. Okay, so we're loading it all up in here. So our particle program uses circle vertices and frac shader assets, particle frac. So what I'm thinking is that maybe instead of circle vert, we're going to use the regular one that is used by the regular program. So essentially we have to use rect, because now what we're rendering essentially is just a rectangle. We just have to make the circle slightly different. Furthermore, maybe we won't even need to adapt anything in the particle fragment shader, right? Do we need anything in the particle fragment shader? So here we accept color, UV, and surprisingly, I guess that's it. So this is going to be the whole thing. So the only thing we had to do, we had to remove, yeah, we have to remove circle vert. Yeah, we don't need circle vert anymore. That's what's interesting about this entire stuff. That's actually cool. We don't need circle vert. Okay, so if I try to recompile this entire thing, it should automatically work, I think. And okay, that worked. That's precisely what's the end result has to be. Yes. Okay, so I just have to swap out one shader, one vertex shader for another one, but the fragment shader actually stayed the same. That's actually super cool. That is actually super cool. I'm super happy about that. I thought it's going to be a little bit more difficult. I thought I would have to actually modify GLSL code, but that was not needed whatsoever. And I'm super happy about that. All right, so let me see. So because of that, maybe we have to remove the circle vert shader from our system, so it's not needed anymore. So I'm going to go in here. So circle vert is going to be that now, and let's try to recompile this entire thing. So let me see, circle vert. Okay, so we don't have this thing anymore, right? This thing is gone, and yeah, so now we have less shader assets. So we used to have 5, now it's 4 of them. So the reason why I have a static assert in here is that I want the compiler to remind me to update this section of code if the amount of assets changes. You see what I'm talking about? So essentially we are initializing 4 shaders, which means we're making an assumption that there's 4 of them. If we modified something, if we modified the definition of the enumeration of the shaders, that means that assumption in this particular piece of code is incorrect. And by the way, this assumption can be checked at compile time, and that's precisely what I'm doing. It's a pretty neat trick. And it saved my ass so many times in different projects. I absolutely love it. So I'm now doing this kind of stuff. So I'm trying to always think, what are the assumptions we're making in any particular point of program that could be broken but could be checked at compile time or runtime. And if there's something that could be broken but we still can check, I either put assert or static assert, and I try to put as many of them as possible. And that helps in development immensely, believe it or not, because quite often these asserts fire up, and they fire up when I don't expect them, and I always say to myself, thank you past me for putting an assert in here. So asserts are a very powerful tool. Learn how to use them. Seriously. Especially runtime asserts. No matter how powerful your type system is, if you're developing a statically typed compile language, no matter how powerful it is, no matter how many things it can check at compile time, any useful program actually accepts user input, right? And outputs something to the user. And none of these things can be checked at compile time. That's the point of an interactive program, right? So none of these things can be checked fully at compile time, or maybe some of them can, but not all of them, right? And yeah, so it's quite important to have asserts for things that may break. Not only that, but I mean, for the user input has to be actually properly checked, not with asserts. Yeah, I'm sorry, talking bullshit. Yeah, the user input has to be actually processed properly, not with asserts. It's like usually asserts are useful when one piece of code making an assumption of another piece of code working correctly, right? But that assumption may break at any point. And this is very difficult to check at runtime. This is what I was trying to say. Like, I wasn't trying to talk about like the user input. The user input has to be like checked properly without an assert. Asserts are usually for different parts of program that depend on each other working correctly. But sometimes it's like very difficult to check at compile time, if that makes any sense. Anyway. So what's going to be the next issue? Basically, this issue is done. So we need to do a committee and then pushy, and we are good to go. So since we removed the circle vert, right? I need to remove this file as well. It's actually the biggest file in here, surprisingly. This is probably because we put a lot of effort into transforming center and radius into like quad and UV card. Yeah, that's precisely what we're doing in here. So that's probably why it's so big. All right, so let me recompile this entire thing, and let me see. All right, so let's do a committee. So remove circle vert and use rect vert in the particle. Bro, it's not gonna fit. It actually fit into the entire thing. Okay, I had 2 characters before I like went over the limit. Okay, and let's push that right into the repo, and let's create a pull request to check for all of these things. The first pull request of today's stream. Isn't that exciting? I think it's goddamn exciting. My god. So we're just waiting for all the continuous integration and stuff like that. It's actually, I'm really glad that we removed more than we actually added. I think it's cool. I always love removing the code. The less the code, the less the code you have, the less the bugs you have, I think. I don't know. It depends. It depends on the density and where exactly the bugs are concentrated. It also depends on the definition of a bug. So we're only waiting for macOS. And now we're only waiting for Windows. MSys2 mean GW. Come on, Windows, I believe in you. You can do it. You can do it. It's kind of ironic how, you know, GitHub is now a Microsoft product. Windows is a Microsoft product. Windows builds on GitHub are usually the slowest ones. So what's going to be the next issue? We need to think about the next issue. Loading config from file panics instead of providing error or recoverable interface. Yeah, that's actually very interesting. That would be cool to implement in my opinion. But maybe, well, maybe it's not that important. So the main problem with this thing is that we have a hot reloadable configuration, right? So essentially you have a game and the game has a lot of parameters. The worldwide parameters, like for example, gravity. Gravity is not part of the... Oh shit, we need to actually add gravity to the configuration. But yeah, things like gravity has to be in the configuration. So it's just like different things in here. And for instance, you can see that the player has a health bar, right? So the player has a health bar. Let's actually zoom in a little bit. And the width of the health bar is described here. So what you can do in here, you can change it and then you can hot reload this entire thing. Just a second, and there we go. So yeah, so we have this sort of hot reloadable configuration and whatnot. And if you make any syntactic mistake in here, right, for instance, maybe you have a variable that well, it's not a syntactic one, but we can try to do it like that. The whole game crashes. It tells the problem though, right? It tells the problem and where exactly this thing is located, but it crashes the whole game. But I think it shouldn't, right? It shouldn't crash. It should just at runtime tell you, I couldn't reload this entire thing. Sorry, uvu. That's precisely the error message has to be like, it has to contain uvu, otherwise it's not gonna work. So it's a little bit annoying, but isn't that important? Maybe it is, maybe it is. Maybe we can work on that, right? So, so today is a Saturday, today is a weekend. Maybe I want to just do a chill stream where I could just work on this kind of stuff. Yeah, I guess we can work on that. Okay, let's just merge this pull request and see. So cool. Naizu. Okay, let me go to the master and fetch the latest stuff. Fetch the latest stuff. Origin master. And let's remove this thing. Alright, so let's grab this issue. Reload config from file panics instead of providing error recoverable interface. 68, not even 69. What was the 69th issue, by the way? What was the 69th issue? Ah, it was a pull request. Okay, boring. So let's create a branch 68. And let's find the function called reload config from file. And where is it located? I think it's located somewhere in here. And yeah, that's pretty much what we have in here, right? So essentially every time you encounter some sort of an error, it's like, I'm sorry, and panics. So I suppose what we want to do in here, maybe instead of panicking, right, we're gonna return boolean. It's just, I chuckled because after saying panicking, I was thinking about the Star Wars joke, but I couldn't come up with one. Panicking. All right, so so dumb, I'm sorry. Yeah, but we can also potentially panic in other places, especially with like a parse config content, right? So this thing, parse config content. So we're using like a special thing that parses things for us. Parse config content, right? So you provide the content, You also provide the file path for the things. Yeah, it can also panic at any time. It can also panic, but it doesn't provide any error messages. I guess the main problem here with the config is when it fails. Where do we provide the? How do we provide the error messages? How do we provide them? Maybe we're gonna have some sort of a buffer. Yeah, it could be something like yeah, it could be a special global buffer for the config loader through which it communicates its error messages, and then you can always grab that error message and display it somewhere. You can put it into the standard output or to the screen. This is one of the things I want to be able to do. So the same error messages has to be displayable in the in both std out and the screen in image and stuff like that, if you know what I'm talking about. All right, let me see. So I'm using AIDS, which is the replacement for C++ std. Yet again, if you never heard of it, I really recommend to check it out. So, and I'm using it in my games because I think std, C++ std, is a little bit overcomplicated for what it's doing. Okay, std replacement for C++. Genius name, I know. So the idea of this entire replacement is that it, like, tries to, it's basically programming in C with classes, right? It's built on top of libc, and it just uses the minimum of C++ features, right? And by the way, things like println that you probably saw me using in my game, like println probably. These things are from that library. So in println actually acts more like write a len from Pascal. I don't know how many people who watch me right now actually programmed in Pascal, but essentially you can interleave different types and it will just, you know, print their textual representations and just concatenate them. So that's how it works. Actually, as a matter of fact, each individual call in here will be translated into a separate like printf, right? And the specific printf will be dispatched based upon the type of this value, right? And println is implemented using C++ 17 variadic template magic. We can even take a look at it, I think. So it's a println. Well, it's a sprintln, which prints things into string buffer, which we're going to use, by the way, for error reporting a little bit later right now in the stream. But the idea is pretty much the same. So we accept a variadic template of types, and then we have a pack of arguments of different types, and we unpack these arguments into a sequence of calls of just sprint1. And through overloading, we dispatch between sprint1s depending on the type of each individual argument. So that's basically how it's implemented. It's actually pretty simple, pretty straightforward if you know how C++ 17 variadic templates work. They're really useful for this specific feature. So essentially, in a loader we have like a global static variable which holds the content of the configuration file. We need to hold the content of the configuration file because we refer to it from different places. So maybe we're going to do a similar thing for the string buffer, right? So it's going to be string buffer. The problem with the string buffer is that it's like a string view on a string buffer, right? So let me take a look at the definition. String buffer. Yeah, it's like it doesn't really do things at all properly. It would be better if string buffer was defined slightly differently. It would be way better if it was actually holding that data somewhere inside. Let me see. So it can be no white spaces. It could be like templated, right? Template. Okay, this is a little bit inconvenient type name. I'm using the wrong mode, by the way. And it's going to be actually holding its capacity, right? So let's imagine that it has its capacity, then this data is going to be like this capacity. There we go. And then you would have things like sprint1, which are also templated, right? Which are also templated that take the size of this capacity and so on and so forth. Which probably would reduce the compilation time immensely. I don't know why I keep using this word, but I kind of like this word. Dramatically. Let's try to use a different word to exaggerate things. Okay, so that will reduce the compilation time dramatically. Because it needs to instantiate templates and stuff like that, but that will be kind of cool because I would be able to just, you know, do something like string buffer. Let's say I want to allocate 640 kilobytes because it's obviously enough for everyone. Something like this. And this is going to be my error buffer, right? And every time a loader, right, fails, I actually print the message into that buffer, right? I just print the message into that buffer. And regardless of its size, it dispatches like correctly. And on top of that, we can use this capacity for boundary checks, right? We could use that capacity for boundary check. And because of that, we don't need this capacity in here, right? But the problem also is that for each like version of string buffer, right, you have to generate a version of sprint1. But on top of that, maybe with a good compiler, some of these small functions could be optimized away and whatnot, right? Because it could be inlined and whatnot. But since they are sort of like public, I don't know. I just want to see if that's a generally good idea. Just want to see if it's a generally good idea. Because right now, this thing expects you to first allocate that buffer somewhere and then create a view on this string buffer, which is not particularly convenient. I just want to allocate the string buffer over particular size. And I think we even had something like fixed region, which is essentially that, right? Which is essentially that. So maybe I just need to like implement printers into fixed regions so I can use it. Yeah, alright, okay, so this library is a mess. Okay, it's in the middle of like, you know, figuring out what exactly I need and what is the minimal things that I need, and just removing everything else. So, and you can allocate things into the fixed region, which is kind of interesting. So we can use it as an allocator. But yeah, I'll see what I can do in there. Anyway, so let's make a cup of tea. Let's make a cup of tea. Maybe I'm gonna even do a small break because yeah, I almost streamed for like an hour. I think it's time for a break. Make a cup of tea and listen to some music. All right, so let's listen to smooth jazz. All right. So let me set the text mode. 3 minutes. I think I'm gonna switch to a different song. Okay. Let's make some break. You guys have fun. Yo. Okay, so I'm just waiting for my kettle. And let's go. So I'm gonna have something like char error buffer, error message buffer, right? So this is error message buffer, and it's gonna have a particular capacity, I suppose. Error message buffer capacity. So there we go. So we have a capacity of this thing, and let's actually define it as a const. And how much do we want to allocate for error messages? I don't know, like 16 kilobytes should be enough. Even 16 kilobytes for an error message is too much, in my opinion. So this is a pretty big error message. I don't think it's even 16 kilobytes. So usually, by the way, when people load in shaders and whatnot, right, so they use the function to get the error message from the shader. Maybe we can force a user to provide this thing, but maybe not. So, and usually people allocate a buffer of a size of 1 kilobyte. Right, it's just like usually 1 kilobyte. Maybe we can do the same. Let's say it's gonna be like, yeah, 1 kilobyte. Why not? 124 is actually 1 kibibyte, so 1 kilobyte is 1000. But maybe we're gonna allocate 1 kibibyte because it's like a power of 2, and we are programmers and we love powers of 2. Right, so my kettle is ready, so I'm gonna go to the kitchen, pour myself a cup of water, and I'm going back. Don't go anywhere, it's gonna be super fast. Yes, it's gonna be super fast. Yo. Was it super fast? Told you it's super fast. All right, so here's the error message buffer, and maybe you want to actually create something like static string buffer, and this one is going to be error message string buffer, and it's going to be just initialized like this. So capacity is going to be this, and its data, if I remember correctly, according to the definition of the string buffer, according to the struct string buffer, right, and this is going to be the data, error message data. Okay, maybe this is how I should call it, error message data, right? So, and this was one error message data capacity, error message data capacity, and this one is error message buffer, which has its error message data capacity and the error message data. There we go. So this is just like the actual chunk of code we're operating on, right? And string buffer is the interface for aids to actually print this thing into, if that makes any sense. Okay, so all right. What we're gonna do in here? So, maybe we could have a function to get the last error message. Something like string view. Config loading error message like this, and this entire thing is going to just return you the last config loading error message, pretty much, right? It's pretty much going to be that. And let me see. Config loading error message. So do I have a way to convert a string view? Yeah, I can. I actually have a way to do that because it just has a view. So that means I can just take error message buffer and view, and it automatically converts it to a string view. So and you can use a string view for your string view purposes, right? For your dirty string view purposes. That's what you can use it for. All right. So essentially, when you're going to be calling reload config from file, if it returns false, you have to just call this function to get the latest error, and you can print this error to standard error. Or when we have an opportunity, we have a capability to render text on the screen, we can also render that on the screen. So yeah, essentially. But of course, after the next reload config file call, the error message buffer will be invalidated, right? So essentially its size will be set to 0, and yeah. The cool thing about this buffer is that if you keep printing into that buffer and you overload its capacity, it's going to be automatically truncated, so you don't have to worry about this kind of stuff. All right, so we clean up the buffer, and yeah, now essentially we can just take the content, right? So here's the content. We're reading this entire thing, the entire content of the file, right? So this thing is a maybe content actually. This thing is a maybe content, and if maybe content doesn't have a value, right? It doesn't have a value. Instead of panicking, right? Instead of panicking, we're gonna be doing sprintf, sprintln actually, and we're gonna give a pointer to error message buffer, right? We're printing this entire error into error message buffer, and that is essentially it. Right, so could not load file because that, and that, and then I can just return false, right? And panicking in here is not really needed. Panicking Skywalker. To be fair, like panicking Skywalker. Panicking Skywalker could be like a cool library for Rust or something to handle panics or whatnot. So yeah, feel free to use that idea if you want. Maybe somebody already actually took that name. Let's actually see. Panicking. Nobody actually took this name. Maybe Panikin. Okay, I don't know how you spell it. I'm sorry, I'm not a Star Wars fan, so maybe I just actually misspelled it correctly. Anyways, so and now, if content is alright, we have to do something like content, maybe content unwrap, right? Then we check if we do have a content owner. In that case, we have to destroy the content and make a new content owner, and just continue this entire thing. Interestingly, we also have to modify the parse config content, right? We have to modify parse config content. And the callback should return some sort of boolean to indicate for the config, for the parser to actually stop parsing. Right, for the parser to stop parsing, and let me see. So where do we have it? So this is the parser. Parse config is going to be boolean, right? And the callback is going to be actually returning boolean. So here is the value, and if not callback, return false. Otherwise, if you successfully parsed everything, we're going to return true. So basically, through a callback, you will be able to actually say something. You'll be able to actually say something. Interestingly, so we also report errors in here. Right, we also report errors in here, so there's also parse config value, and it may return you a config value or not return you a config value. So we'll have to think, how can we get rid of that? We also want to be able to hook up these error messages into our error reporting thingy. Maybe because of that we have to consolidate this entire stuff. I don't know. Because loading the configuration loading the configuration and parsing it is pretty much the same thing, isn't it? I think it's pretty much the same thing. Yeah, but the thing is, this parsing should be also reused by our config indexer, and config indexer is actually a very interesting thing. It's a program, it's a separate executable program that generates this index out of the configuration, right? So here you have this configuration. We run a special program, and that program generates this C++ code from that config. And you can take this meta information about the configuration and compile it with your game. So then later, this like information helps you to reload this configuration at runtime. Right. As you can see, you have a sequence of configuration values, and you have a table information of each individual variable, their type and whatnot. And we also have the names of the variables as macros that redirect to the corresponding slots within this array. Right, and that is automatically generated by a separate program. So it's a little bit of code generation metaprogramming thingy. What's interesting is that there's also a special mode of this thing. So if you run it like this, it's actually very easy to use. The config indexer is actually super easy to use. You just provide it the vars file, right, like this, and it just generates you this thing, and you just can redirect it to the file. But it also has a flag bake, which essentially, as you can see, turns this entire thing into compile time values. It basically bakes these entire values into the executable without an opportunity to hot reload them. And this is usually used for the release build, right? In release build, we want to make these things compile time values, so the compiler has an opportunity to perform constant folding, right? Constant folding, and actually make the code more optimal. So basically, we give the compiler more information about what's happening, so it can optimize it a little bit better. Yeah. Constant folding. Okay. Yeah. Okay, that's precisely the reason why we do all that. I usually always put support links in there, so but I'm gonna just have like a reminder. All right. So. So I think, yeah, and the indexer actually reuses the parser. So we use the same parser between the program and the indexer. So if I'm gonna merge parser and the loader, so that means the indexer is gonna be using the loader, which kind of makes sense, which is totally fine, I guess. I guess it does make sense. All right, so I think what I need to do right now, I need to consolidate these two things together into a single translation unit. So I need to get rid of the parser. The thing about the parser, it uses the index for some reason. I see. Why does it use index? Does it need index in any way? Config index by name. It feels a little bit strange. It's... Oh, I'm looking at the wrong file. I thought I was looking at the parser. Okay. I need more tea, I'm sorry. I just need more tea. Oh my god. Yeah, I just was looking at the wrong file. Relatable, am I right, fellow programmers? My face when I'm looking at a different file. Config type by name. And all right. So what I'm gonna start doing, I suppose, is basically consolidating all that. All right. So I'm gonna be moving things from parser to the config loader. So we're gonna have things like config type name. There we go. The config loader needs an index because otherwise it won't be able to load it. It is really complicated. It is really complicated. One way I see we can actually fix that is by moving the error message data into the parser. I guess that's one way to do that, and loader is going to be reusing the error message buffer of the parser because it's kind of like related to that. It's kind of like related to that. All right, so that's basically what we'll have to do. All right, so let me actually remove some of these things in here. So this is going to be that. So yeah, this is not needed. This is not needed. And first thing I want to do, I want to basically introduce the parser translation unit. Yeah, so let's introduce the parser translation unit because we have translation unit for loader and we need to introduce the translation unit for parser. Right, we need to introduce translation unit for parser. So we also have an indicer. So just like this is a small part that can be reused by, and the loader is just on top of that. Okay, I guess that's what we need to do. All right. Config parser. So let's include config parser HPP like this. Config loader parser HPP. Come on. All right, so I'm gonna just select everything in here and I'm gonna just put it like that. So this is a CPP and this one is gonna be something slightly different. Okay. Okay, so I just want to have signatures in here. Just signatures, nothing particularly special. Oh, callback. Callback is a template, and it just doesn't allow us to do that easily. Callback is a template. C++, C++, what are you doing to me, C++? I think we can change actually approach to how we parse the config. I think we can change the approach to how we parse the config. It's actually very interesting. Let me see a little bit more tea, and I'm going to explain what I find interesting. I think we could get use. We could make use of immediate parsing. Actually, I don't know why I'm so obsessed with immediate mod stuff lately, but it's kind of like a lot of problems that I encounter. Yeah, you can just solve it by doing that in a sort of immediate fashion, if you know what I mean. Okay, so essentially how our parser works right now. Right, it works in a very similar way to a simple way, in a very simple way. So you have a parser, you have a content, and you provide a callback function, right? A callback function, callback, and the callback is a function. Can I do it like that? Is a function. How can I express the function? So which accepts the definition of the configuration, the value, and the line number at which it happened, and returns you the boolean, right? It returns the boolean indicating that you should stop parsing. So at any point you can stop parsing. So essentially, you setting everything up, right? You setting up, you getting the content. Then you preparing the function that will be called the parser, and you just call parser, and you lose full control of the parsing loop, right? You lose all of the control of the parsing loop. The only control you have is through the callback function that can return boola, and If you return true, that means it will continue parsing, and if you return false, it will stop parsing. That's the only control over the loop you have. You don't have any other control whatsoever at all. What if we go the other way around? What if we go the other way around? So this is one way to do that. What if we just construct a parser, and put the content in here, right? You just give it this thing and you put the content in here, and basically you have a loop, right? You have a loop and you call the parser. It's not an immediate mode, it's actually just why do I call it immediate mode? It's just like, it's not even that interesting of an idea, so people do that all the time. I don't know, like next value, and this entire thing is going to basically search for the next value, and then it finds the next value and it stops and it returns you the definition value or line number, right? And if it fails, right, it may actually return you something else, right? So essentially we can do something like this. We can have a definition and a value defined in here, right? And maybe even a line number, right? Line number where all of that stuff happened, right? And then I can just do parser next value, and I put these things in here. So this one has to be a value line number, right? So if everything's okay, we've got a new definition and value and we can process it. If something went wrong, definition and value will probably not contain anything, but the line number will contain the place where something bad has happened, and what bad can happen during the parsing? Let's actually see. So it already copy pasted everything. Okay, I already copy pasted it. So we may have that something is not a valid type, right? Something is not a valid type. And another thing, we couldn't parse config value as the requested type. Maybe we can actually describe this kind of errors in the form of a structure. In a form of a structure. So yeah, essentially we can have like a union and whatnot. So we have this kind of type of error, invalid type, and it will give you the type that is like the string of the type that is invalid. And then if you have that, we're going to have a string of the value that we were trying to parse and the type which we were trying to parse it with. And that way you don't need a callback because you are in full control of your loop, right? While parser not finished, you do that, you're in full control of your loop completely. And at any point you can just stop and process these things, and the parser can return you something. I guess that's going to be a little bit better. That's going to be a little bit better approach. I don't know why I decided to go with this one. Maybe because I had many years of functional programming in Haskell and it's permanently damaged my brain and I cannot program in any other way, and I'm sort of relearning the programming again. So there is like a pre-Haskell programming when you first programming for the first time. Then you discover Haskell and pure functional programming and you learn programming yet again, but in a different fashion. And I'm in the phase of post-Haskell when I got fed up with all of that functional programming stuff, and I'm learning the programming that I knew before Haskell yet again. So I'm learning it back. I guess that's what's going on. That's probably what's going on. That's what Haskell does to you, so be careful. Don't do Haskell, kids. I mean, actually do it. It's actually a very cool language, and it can teach you a lot of things. If you never programmed in a pure functional programming style, I recommend you to just try it to learn something new, at least for that. At least for that. Do not recommend writing big projects in Haskell, but just to learn something, I think it's a pretty cool. recreational educational tool. Anyway, so we're trying to parse config value, and yeah, let me get rid of all of that. Okay. So here is my parser, and maybe we need to have something like a parser error. So it's going to be some sort of a structure, maybe parser. Parser result, right? So parser result, maybe something like this, right? It's just a parser result. I don't remember if you put it here. I think you put it here. So, and then we want to have some sort of like a union or whatnot, maybe. So parser result type. Maybe we could introduce actually, since it's a C++, we can do things like this. So this is going to be type, and in here we can have a type as OK. So this is the OK result. Then invalid type, and of course you have to be screaming, right? Invalid type. Yeah, and you can have something like invalid value as well. Invalid value. So you have invalid type, and then you have invalid value, and invalid value happens when you when you declare one type for the variable, but the value is actually provided of a different type, so you cannot parse that value as that specific type. Right, so, and we can just have a type of this situation in here. So, okay, like when you fill it with 0 is just, you know, it's just okay. So everything is okay, don't worry about it. Don't even worry about it, everything's fine. So pass a result. So on top of that, maybe we can have, maybe we're gonna return definition value and line. Definition value and line in the parser result. That sounds like a cool idea. Definition. So we need the definition value and line number. So config value definition and then config value. Right. So parse config value, right? Yeah, you have config value and config value definition. Config value definition. Maybe it shouldn't be called type because we have a type of the configuration value, so it's going to be a little bit confusing. Let's actually rename this to status. Right, so this is going to be the status. And this one is also going to be a status. So we have a config value definition and then config value, which is just a value. And now we need to have the strings for this entire thing. So if it's an error, right, if it's an error, yeah, this thing has to be a union, right? This thing has to be a union. Okay, so in here, it's going to be something like parser, maybe parser OK, right? So this is a parser OK, and this is what we're going to store in here. It's going to be parser OK. And maybe this thing has to be a union. Parser OK. Okay, there we go. So here's status parser OK, and then maybe you're going to have something like parser invalid value, right? It's going to be like this, and invalid value is going to be what? Invalid value is going to contain string view. Let's start with the type. Type name, right? So this is going to be invalid type, and there we go. So parser invalid type, right? And then we need to have something like struct parser invalid value, right? So it's going to be like value. You're going to have a status. Then you're going to have the expected type, right? It's going to be config type expected type, and then it's going to be string view value, the actual value that you got. Right, and in here we're going to have a parser invalid value. There we go. So yeah, you have a union, and depending on the status, you can basically dispatch between them. Algebraic data types in C++. Who said that you cannot do that in C++? There you go, algebraic data types. Okay. So now I need to restructure all of that. So what I'm thinking is that like parse config content. I'm thinking is that what if like I want you to have like a structure parser, right? So parser. Alright, what if I put all of these things inside of that structure parser? So that way I won't need to, I don't know, prefix them with parser. Right, I can just have a result, right? Then invalid value, invalid type, this. And maybe status could be also outside, right? Status could be also outside, and you can have all of these things in here, right? And when you're constructing the parser, you should give it the content that you want. You should give it the content that you want. So what's going to be the content that you want? It's going to be string view content, right? String view content, and and it definitely needs like a something like a next definition. Maybe something like next, right? And it's going to return you a result, right? And the result OK returns you the definition and the value and so on and so forth. So I don't think it's going to be accepting anything, right? I don't think it's going to be accepting anything. Though we need a line, right? So maybe the result is going to be actually also returning you a line number, right? And if we're going to be putting a line number in here, we have to put it to each individual structs in here, right? So this is the status, this is the line number, this is going to be that, right? So, and that's basically what you have to do in here. And when you do next, the question is, maybe we're going to be actually maintaining the yeah, what if we maintain, so the line number actually starts from 1. We can maintain the line number in here, and by default the line number is going to be actually equal to 0. But I mean, it's like we're following zero initialization rule, and that means you can just allocate it in some sort of memory, zero initialize it, and it's going to be a valid parser, right? It's going to be a valid parser. So you can have a line number, and maybe because of that we don't have to return the line number from here, because you can just always grab the line number from the parser itself, right? You can just always grab it from the parser itself. So because that's the crucial thing in here, like you always call next and you can get the current line number. All right. So let's implement this function. So this function is going to be just that, right? So it also has a file path, and it doesn't need to know file path. The only reason why it needed to know file path is because it needed to report it. But now whoever calls the parser knows the file path, so they can report accordingly. So we don't need to do that. So it's even better design generally. It's just generally better design. Okay. And here is the thing. Here is the thing. So the first thing you try to do when you're calling for the next, right? You get in the line, right? You chop the lines. Well, it has to be called content. Maybe I can query replace lines with content like this. Okay, it's called only once, so it doesn't matter. So here's the line, and then you trim everything. And here is the interesting thing. Here is the interesting thing. If line, right, if line count is equal to 0, you have to repeat this entire process. You have to repeat this entire process by the virtue of copy pasting. Okay. And what I'm thinking is that this looks like a job for do while, doesn't it? I think this is a job for do while. Okay, so here is one version of this thing. Right, it's going to be something like this. And the next one is going to be, how do you implement that with the do while? So we have something like this, you zero initialize it, and then you do, and you just do this thing once. And while line count is equal to 0, you keep repeating that. So because you need to try to do that at least once, right? You need to try to do that at least once, and yeah, there you go. So I think like this versus this. Who said that do while is useless? Who said that? Mot? Ban? Permanent. It's gonna be funny if there is a bug in here. Anyway, so we also have to probably check first whether we finished. So how do we indicate that we finished parsing though? How do we indicate that? We can indicate it through result, I guess. So we have a parser OK. Means status OK. You can have another one finished. You can have another one invalid. Right. You can have another one invalid. And so on and so forth. So finished is probably not going to have any particular representation, right? It's not going to have any particular representation. So there, I'm just thinking, who should be the 0 one? Finished or OK? I think finished should be the 0 one because, yeah, zero initialization rule. You take a result, you fill it with zeros, and it should be valid result. And what kind of result should it be? It should be the most useless one. I guess finished is the most useless one. I don't know if it's like it's just like the general principle that I'm trying to follow, right? So I guess it makes sense. Finished, maybe success. This one could be success. So there's a finished success. Then you can have invalid type, invalid value, and here we can have something like success. Success. I don't really like the OK. I guess we can just call it success. Right. So this is a success, and again, we don't need to actually prefix them with anything in here. So we just have status, success, invalid type, invalid, blah blah blah. Though what's interesting is that if you encountered the problem, if you encounter the problem, so for example, you got invalid value and you try to call this thing again, right? Should we like sort of jam the whole parser and not allow it to do anything? That's an interesting question. That's another interesting question. And because of that, maybe we should store this entire things, like this result stuff, inside of the parser. It almost feels like the parser wants to like own these result things. You know what I'm talking about? It almost like it wants to own them. Not sure if it makes any sense, but if it owned them, right, if it owned them, it would be relatively straightforward, I think. Would be relatively straightforward. You could return the status, why not? It could be rather convenient. So, for example, if status equal success, we try to do this entire thing, like we try to parse next. Otherwise, don't even try to do anything and just return the status. So essentially, if you ever hit invalid type, invalid value, or finished, right? If you hit any of those, it will just jam the whole parser and keep returning the same thing, and it won't go anywhere. And because of that, finished should not be a right thing. Finished should not be a right thing. Right, so finish should not be the zero thing. So because if you create a parser and zero initialize this parser, it will essentially automatically jam it. So maybe the success should be the 0, 1 and the finish should be the 1, and so on and so forth, because in that way you just create a parser, zero initialize it, and it's not jammed first try for the first attempt. You set its content to something, right? You set it to something, and you can just continue doing this kind of stuff, I suppose. All right, so okay, I guess that makes sense more or less. Okay. So if status equal success, right? If status equals success, we're trying to get this thing. Right, so we are taking the line, we're parsing the line, and it's kind of dangerous because you have to be super careful. While line is equal to 0 and content count greater than 0, you keep doing that. Right, you keep doing that. Then, if after this entire loop, the content is equal to 0, right, if content become equal to 0, I mean, this is actually quite dangerous. Okay, if after this entire stuff line count is still equal to 0, we finished. So we set status to finished and return the status. That's it. Nothing much to do. Nothing else has to be done in here. Okay, so we prepare the definition, right? We prepare the definition. And since we sort of own, maybe success in that particular case has to be actually one of these things. Yeah, let's actually inline this entire stuff. I think success is also sort of redundant. So we have type invalid type. Yeah, if the status is one of these things, you'll have to look into these structures. So we don't union them, we don't compress them with union, but I don't think it's that important. All right, so in here, I'm basically going to be resetting the definition. Right, and in the definition, do I set the definition to, okay. So essentially, I don't even need to do that. I reset the name. Then I take the type name. I think I would call it type name rather. So this one is going to be called type name. and it sets it to the definition type. And instead of panicking, what I'm going to be doing, I'm going to be setting status to invalid type, right? Invalid type, and inside of the invalid type, I'm going to be setting the name to that specific name. And then I can just return the status right away. Then I can just return the status. So when I'm trying to parse the value, right? When I'm trying to parse the value, I'm just doing that. Right, so this is going to be the value. All right. And it's not particularly convenient. Speaking of, I don't think yeah, we don't have a callback anymore. We don't have a callback anymore. So in here, every time I take the next line, by the way, I need to increment line number. Line number plus 1. There we go. It's going to be line number plus 1. So we have a line, we just get the next line. If we couldn't get it, we just do the finished. So tab name. I want to kind of refactor this entire thing. So where is this function? Yeah, I wanted to return config value via the arguments in here. Right, so this is going to be that, and here I would just want to return a boolean to indicate that you couldn't get the value. That's what I want to do in here. So that will require a lot of refactoring, but it's not that hard to do. Okay, so once we got that, so I'm going to be actually having string value. Okay, so this is the config value. This is the actual value, but we set the value. Yeah, we already have a value, so we don't need that. So that means I can do something like parse config value sv def type and a pointer to the value. Yeah. And if this thing failed, we instantly say status invalid value, then we take invalid value expected type, I think it's what it's called, right? Expected type. So, and we do have the definition of the type, right? So here is the expected type, and invalid value. I think this is the value sv essentially, right? So this is the value sv, and then we just return this status, right? So after that, we just return the status. So we successfully parsed like one thing, and that's pretty poog. So you have the content, you have the line, and I think the parser became a little bit simpler, and I guess that's pretty much it. I didn't think we need anything else. So obviously this entire thing doesn't compile because it has a lot of compilation errors. And you probably noticed me making a lot of compilation errors, but that's the point, because we are programming in a statically typed compiled languages, and if you make any mistakes, this language will tell you, and you just have to go through all of these mistakes and fix them, right? Isn't that convenient? We had this kind of idea for decades, since I'm probably since 60s. Yeah. But then TypeScript came out and everyone was like, whoa, whoa. All right. Let's try doing a pile of shit. So we're gonna go on the compiler assist refactoring session. Basically, I'm just gonna go through the compilation errors and fix them until they're fixed, essentially. All right, so here is this thing, right? So this function no longer returns maybe or anything like that, right? It returns a config value. So maybe I'm gonna actually rename this thing to result and get rid of the result, right? So let's see what's gonna happen. So this one has to be like this, another one, another one, another one. So and in here we just return I suppose just true. And what's interesting is that maybe we also could replace return. Oh, in C++, this is a valid code, right? Wait a second. So if I have something like main CPP, right, and I have a boolean f function, right, and I return something like this, and maybe I can include IO stream, right, and just std cout f std handle, right, is that the correct Z++ code? Oh shit, it is correct C++ code. You know what actually bothers me in C++ is that when you try to print boolean through cout, it doesn't print false or true, even though they do have an opportunity to correctly dispatch at compile time by the type, but they just decided not to. I don't know how exactly it's implemented, but it's just like something that bothered me in C++. You have a technical ability to just do that because you have a stronger type system, you have compile time dispatching between the types. You could have just dispatched on boolean and print true or false. Maybe, I don't know what was the reason, maybe they were trying to avoid some common leg shooting, because they also need to interact with C, and C used integer as the booleans, and it's just like, I guess there's some sort of like a lore behind this thing. But anyway, okay. So let's actually continue compiling this entire stuff. So what do we have in here? Okay. So what is this function? I think we don't need it. Yeah. This is the function that I was trying to get rid of. Yes. Okay. So yeah, we have a parse config, and I think it has to be defined after. Wait, what did I remove? So parse config value. Okay. So parse config value, and oh, okay. I think I removed more than I needed. All right. So here's the parser, and here is the status. And status, I suppose, because of that, has to be defined like somewhere here. Right, it has to be defined somewhere here. I only have 10 minutes. I learned yesterday that I shouldn't stream for too long. Otherwise, processing the video on YouTube takes very long time. So if I stream too long, I already shifted the time by which I can upload something, and processing shifts it, offsets it even more. So it's just like I release the video at night or something, and it's just like okay, so here's the parse config content. So that's essentially what we're doing here. So instead of doing that, all right, so instead of doing that, we have to do slightly different things. Right, we need to organize the parser. So it's going to be parser content vars conf content. That's how we create a parser now. And while parser next equal success, right? While it's equal success. Oh, another interesting thing is that since success is 0, right? Since success is 0, we can just do something like while, which looks weird, but okay. So we can put it like that. On next, what are we doing? Right? What are we doing? We have to take def lines. Okay. So we have config value defs, then we have config def lines, and we take the definition name. Okay, so here I'm going to be doing it like that, and the definition is a part of the parser. So here's the parser definition. So here's the place. And if this entire thing doesn't have a proper value, right, we are panicking, right? We are panicking, and in here it's actually okay to panic. It's actually totally okay to panic. And in here I'm just setting this thing, right? So it's going to be config values push parser value, parser definition, parser line number. And we don't need that stuff anymore, as far as I can tell. I think we don't. And after that, after this loop is done, we need to take a look at the parser. Parser status. If it is, we can actually switch upon that. That's the thing, right? So it could be like several things. Case parser invalid type. So we can have invalid type. So we have to print it accordingly. You have to print it accordingly, and we can also panic. So we can say something like vars conf line number, something like parser invalid type, name is not a valid type. Guess that's it pretty much. Guess that's it. So panic never exits, by the way, so it should be fine. Parser invalid value, right? And in here we just panic vars conf line number. Could not parse this. Parser invalid value. Invalid value. Value could not parse this thing as type as this thing, and we have a way to convert type. Yeah, config type name. Yeah. Config type name is a parser invalid value expected type. Yeah, there we go. And if we have something else like parser success or finished, or maybe we're gonna have like a default, we're gonna just ignore all of that. So, well, to be fair, if you got parser success, right? Success. This is straight up unreachable, right? So unreachable. Parser success, right? Because you shouldn't be seeing that. And in case of parser finished, right? Parser finished, you just ignore that because that's precisely what you're expecting here. So yeah, that's it. There's nothing much to say, right? If it's invalid type, or you report it as invalid type, valid value, same thing. If it's success, you report it as a success, and if it's finished, you do nothing because that's precisely what you're expecting here. But this thing should never be reached. This thing should never be reached. Okay, so content designated. Oh fuck, shit, fuck. God fucking damn it. Okay, so maybe for now I'm gonna just do it like that then. But it would be better to have a constructor of some sort, right? So parser success. Okay, what else do we have? It's a parcel. Yeah, it has to be something like this, parser name or whatnot. Parser. And I think, yeah, config indices are actually successfully loaded. All right, so we are in the main game now. Cool. So, and we need to parse this stuff as well. So let me actually move the code from config indices, right? Config indices to load. All right, so we're moving it to. What the fuck has happened? Okay. Okay. So, and in here we're usually using config file content owner. Okay. Config file content owner, and in here we're just iterating until we see a success, right? So here's the success, and I might as well just use this entire thing in here, right? And similarly, we probably, yeah, there's a little bit of duplication in here with this switch case and stuff like that, but I don't know. At least it gives us an opportunity to have control of that. And the parser itself doesn't have to have any way of printing our errors and whatnot. All right, so that's precisely what I want to see in here. Right, that's precisely what I want to see in here. And here we have a definition name. And this one is going to be parser. Parser. Yet again, maybe another one. Parser. Okay, so here's the config values. This is the parser. And yet again. We're almost done, I suppose. Oh, and this one is slightly different. So what's the file path? I can just replace it with the file path, I suppose. Where's conf path? File path. Cool. I think it's working if I try to run this entire thing. Okay, I refactored the way we parse things. I completely refactored the way we parse things. And with this kind of way, reporting errors in a recoverable fashion from the parser should be a little bit more convenient. But unfortunately, we are running out of time. We're running out of time. So I'm going to wrap up and just put it to do. Maybe like to do is not particularly required. I think I'm just going to make a pull request and not close the specific issue, right? So here's the parser. One of the things probably that's worth making is actually introducing the translation unit for parser HPP, because now parser HPP doesn't have any templates, right? It doesn't have a single template, so you can just put some things into CPP. You don't have to worry about that, which is nice. Maybe that's precisely what I'm gonna do. First, 68 turn parse config content into struct with methods, right? Because in that case it's a little bit easier to work with. And let's introduce something like config parser CPP, and let's include, maybe it's going to be too much time because I don't know how much time it will take. I'm probably not going to do that. Okay, so I'm going to just create a pull request. I'm going to just create a pull request. Did I push it? I forgot to push it. Okay, so let's push this thing in here. So yeah, apparently to make it not crash every time you encounter some sort of error in the configuration requires a lot of refactoring. You know what they say? Just refactor until the change becomes trivial, right? So you're not implementing features, you're not fixing bugs, you're refactoring until the fix is trivial. So, yeah, so today was a pretty productive stream, relatively. We fixed the particles after refactoring the renderer. These particular particles were broken, but now they work again, and this is actually super cool. I'm super happy about that. And we started refactoring the parser, but unfortunately we ran out of time. So it is what it is, and it isn't what it isn't. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you all tomorrow. Tomorrow we're gonna continue doing this shit, because tomorrow is Sunday, the day of the sun, and we're developing this game for the whole weekend. So tomorrow I'm going to continue working on this parser thingy, and you know, fixing this entire thing should be relatively trivial. So my goal is that when I make a mistake in the configuration, right? Make a mistake in the configuration, it just should not crash the whole game. Like, it would be nice if it didn't crash the whole game just because of that. Right, because sometimes I can make a mistake and I don't want to lose all of my state of the game and stuff like that, you know what I'm talking about. Anyway, thanks for watching, and I see you all tomorrow. Love you.